Hi! Today, I can solve complex triangle problems by looking for linear pairs and angles of a triangle and using isosceles, equilateral, and angle bisector definitions. Very, very important lesson, by far the most important lesson so far. It incorporates a lot of things that we spoke about so far. So, first of which being, we want to look for linear pairs, look for angles of a triangle. Linear pair is a straight line that's cut. Once I know one of the angles, I subtract from 180 to find the other. For example, if this is 40, I do 180 minus 40 to come up with the other one. Angles of a triangle, I know if I have angles of a triangle, let's say that this is 60 and this is 80, to find the third, I add them up and subtract from 180. We're going to have to do that. And then we're going to have to utilize what we did in the previous lesson. If I have congruent sides, the angles opposite them must be congruent. If I have an angle bisector, the angle bisector is being cut into two congruent halves. And finally, if it tells me that it's equilateral, I know the angles are 60, 60, 60. So let's take a look at number one. In fact, let's not look at number one. Let's jump right to number two. Always read the question to see if there's anything important. If not, then you're going to be using just linear pairs and angles of a triangle. It says that LO equals MO. Whenever it says that two sides are congruent, mark the sides, mark the angles opposite them. LO, MO, mark the angles opposite them. Those are my two congruent angles. So if angle L is 55, then angle M is also 55. Now we look for linear pairs, we look for angles of a triangle. I see a linear pair, a straight line that's cut. So I subtract 180 from 55 from 180, which gives me 125. Now I'm done. There's no more linear pairs. I look for angles of a triangle. I look for a triangle where I have two angles and I can find the third. I see it right there. So I do 125 plus 28 is 153, and I subtract that from 180. I just used one thing to find the next, to find the next, to find the next. Notice I never even looked at what the question was asking. Just want to find something, and that something will lead to the next thing, which will lead to the next thing. Angle N, I've got it, it's 27. Let's do one more that utilizes, in fact, we can take a look at number three that utilizes the isosceles triangle. Why don't you take a moment and try this one on your own before I take a look at it? All right, now that you had an opportunity to take a look at it, is there anything important they're telling me in the problem? In the diagram below of triangle ACD, B is a point on AC such that triangle ADB is equilateral. ADB is equilateral, and I know that an equilateral triangle has 60, 60, 60. All right, I dealt with that. I read on. And triangle DBC is isosceles with DB congruent to BC. Very important. When they tell you that two sides are congruent, mark the sides, mark the angles opposite them. DB, BC, mark the angles opposite them. All right, I look for linear pairs. I look for angles of a triangle. Linear pair, a straight line that's cut. 180 minus 60 is 120. Angles of a triangle. I see a triangle. Even though I don't have two angles, since I marked that those two are the same, we know we can subtract what we have from 180 and then divide that by 2 to get 30 and 30. Angle C is 30. So that is how we deal with isosceles and equilateral being incorporated into the complex triangle problems. Either way, you're going to look for linear pairs. You're going to look for angles of a triangle. Let's now skip ahead to number 8, where it says that AE bisects angle BAC. Well, BAC, if BAC is being bisected, that means that those two angles are going to be congruent. It says that angle C is 50. It says that ABC, this whole angle is 60. And it's asking for, well, I don't care what it's asking for. I need to get started. I'm looking for linear pairs. I'm looking for angles of a triangle. The only linear pair that I see, well, I see a couple. I see this one. I see this one. I see linear pairs in here. But there's nothing that I can use yet. In fact, in this particular question, I don't think I'm going to need any. So I look for angles of a triangle because there's no isosceles here. So do I see a triangle where I have two angles and I can find the third? Let's have you look for it for a moment. Look for a triangle where you have two angles and you can find the third. I see it. It's the big triangle. So I do 60 plus 50 is 110. 180 minus 110 is 70. Now, since that 70 is being cut in half, I'm going to fill in 35 and 35. All right, linear pairs still don't help me. I'm going to look again for angles of a triangle. I now see two triangles where I have two angles and I can find the third. I see this one. I have the 60 and the 35. So I do 60 plus 35 is 95. I do 180 minus 95 is 85. I believe that's what they're asking for. FEB is 85 degrees. So either way, you're looking for linear pairs and angles of a triangle. We actually did not use any linear pairs in this problem. We did use a couple of pairs of triangles. But if it tells you that an angle is being bisected, that angle is being cut into two congruent halves. Let's do one more with angle bisector, and then it's up to you to practice. It's a very, very important lesson. I don't want to do it all for you, but it's very important that you spend the time on this. It says that angle M and angle O are bisected. So angle M is cut in half, and angle O is cut in half. It says that N is 40. We got that already. TMR is 28. Well, this is 28, and this is 28, and this whole thing is 28 plus 28, which is 56. I'm looking for angles of a triangle. I'm looking for linear pairs. I see a triangle where I have, in fact, I see two triangles where I have two angles and I can find the third. I'm going to go with this one. And again, you have to just look for them. 56 plus 40 is 96. 180 minus 96 is 84. 84 divided by 2 is 42. So this is 42 and 42. I'm just going to, well, what am I going to do? I see another triangle where I now have two angles and I can find the third. I see this one. I'm just going to remove that 56 because it's kind of in the way. I don't think I'm going to need it. So now that I have that one, I have the 42 and the 28. So 42 plus 28 is 70. 180 minus 70 is 110. Now that I have that, I have a linear pair. 180 minus 110 is 70. I think I've answered the question. OTS is 70. And in case you're saying, well, Mr. Schlansky, how are you seeing all of this? You have to look. Okay, you have to look for linear pairs, look for triangles where you have two angles and can find the third. That's why the objective of this lesson, the number one objective, starts with I can solve complex triangles by looking for linear pairs and angles of a triangle. That's what you need to do in order to be successful with these questions. And in addition to that, we can incorporate isosceles when I have two congruent sides. I also mark the two congruent angles opposite them. If I see an equilateral triangle, I can fill in 60, 60, and 60. And if I have an angle that it says is being bisected, it's being cut into two congruent halves. Definitely spend time and practice on this one. It's a very important lesson. The most important lesson so far. And that's all I got on my end. See ya.